Great, continuing lesson 1.7. A couple things we want to cover here. If you look at some vocabulary we have here, it says a variable is a symbol. So I've already talked about this. A variable, it says in this case it's a placeholder for a number, but it's a symbol that represents a number. Right here, it's a symbol. Okay, so we can't freak out when we see variables. They just mean an unknown number. And our job is usually to figure out what that number is. If a proportional relationship is described by a set of ordered pairs that satisfy the equation y equals kx for some number k, k is called the constant in proportionality. Okay, and that's what we're talking about here. K is that constant. And we can use that constant to write equations. Okay, so let's look at an example that I'm sure you've all dealt with before. Brandon came home from school and informed his mother that he had volunteered to make cookies for his entire grade. He needs 3 cookies for each of the 96 students in 7th grade. Unfortunately, he needs them the next day. And I know some of you have probably done that to your parents before. They determine they can fit 36 cookies on 2 sheets. So is the number of cookies proportional to the number of cookie sheets used in baking? Well, is there a number we can multiply by? Is it going to increase by the same rate each time? Well, my answer is yes. Because if you fit 36 cookies on 2 cookie sheets, well then if you doubled it to 4 cookie sheets, then you'd fit double 36 to 72. And that's what we're going to do next right here. We're creating a table, and this is a really good strategy. So again, we're going to have the number of cookie sheets, and I'm sorry, this is sloppy. And then we have the number of cookies. Oh, goodness. Should have left more room. Number of cookies. So I'm just going to say number of cookies. And then we will have our unit rate. And we're going to say our unit rate is cookies per sheet. Now that is our y over x. So that means, I'll put a different color here. Our number of cookies is y, because again, it does make sense to say sheets per cookie. And our number of cookie sheets is x. So let's fill in our information. If I have 2 cookie sheets, that's 36 cookies. If I double 2 cookie sheets to 4 cookie sheets, then I'm going to double 36 to 72. Let's say I triple 2 cookie sheets to 6. I'm going to triple 36, which if you did that on a calculator, you get 108. And remember, we said this was proportional, so I anticipate my unit rate or my constant, both, are going to be the same. So if I take 36 divided by 2, I get 18 cookies per sheet. If I take 72 and divide it by 4, I get 18 cookies per sheet. If I have 108 and divide it by 6, I get 18 cookies per sheet. So our unit rate is 18, our constant is 18, and explain the meaning of the constant. There are 18 cookies per cookie sheet. Notice right here that they're the same answer. A lot of times we think math has to involve so much work, and right now it's about understanding. If you know what the unit rate is, you know what the constant proportionality is. So a hint for your homework is don't stress out, thinking maybe it's too easy. Find the unit rate, then you know the constant. Okay, so let's finish this problem up. It says takes 2 hours to bake 8 sheets of cookie. Well, 8 sheets of cookies, if they begin at 4, when will they finish baking? Well, let's start out with how many cookies does he need. If you come back up here, he needs 3 cookies for 96 students. 3 cookies per student. So if I go 3 times 96, I get 288 cookies. That's the total number of cookies I need. We know that there are 18 cookies per cookie sheet, So if I have 288 cookies and I divide that by 18, that'll tell me how many sheets of cookies. And that, if you figure that out, 288 divided by 18 is 16. So I have 16 cookie sheets I need. Now, it takes 2 hours to bake 8 of them. So they're starting at 4. So they start at 4. 2 hours later would be 6. And that means they've done 8 sheets. 2 hours later would be 8. And if they've done 8 more sheets of cookies, that would be 16 total sheets. So they will finish at 8 p.m. All right, let's look at one more example. A little different here. But again, it's that idea of we got to figure out, just figuring out what we need, our constant. So Suzette and Margot want to prepare crepes for students in their French class. A recipe called makes 20 crepes with a certain amount of flour, milk, and 2 eggs. They already know they have enough flour and milk, but they want to figure out how many eggs do they need to make 50 crepes. All right, so we need to figure out how many eggs we need for 50 crepes. Okay, so we know we have 2 eggs. Sorry, that's eggs there. Per 20 crepes, and that comes from right here. Now I can reduce this. Let's say I wanted to reduce this and divide top and bottom by 2. And I get 1 egg for 10 crepes. That makes it a little bit easier by reducing it down. That makes it a little bit easier to figure out how many eggs we need for 50 crepes. So what does this constant, sorry, this should say of proportionality mean? Well, 1 egg is needed for 10 crepes. So how many eggs are needed to make 50? Well, to make 50 crepes, we multiply that by our constant proportionality, 1 egg for 10 crepes, and that gives us 50 over 10, or just 5. We need 5 eggs. Okay. So just to finish here, if a proportional relationship is described by a set of ordered pairs, and that comes from our table. We were making tables today. It satisfies the equation y equals kx. There's our constant right there, k. Then k is called the constant of proportionality.